It's 40 degrees Celsius outside, the air feels heavy, and your shirt clings to your back. You walk into a room, and instantly, relief. The air is cool and dry, like a comforting cloud. But have you ever stopped to ask, how does this miracle machine called an air conditioner actually work? The answer lies in some surprisingly simple physics, and a lot of clever engineering. An air conditioner doesn't make cold in the way a heater makes heat. Instead, it moves heat. Specifically, it removes heat from inside your room and dumps it outside. At the heart of every air conditioner is a refrigerant, a special fluid that changes between liquid and gas at low temperatures. This refrigerant flows in a closed loop inside the system, and is key to transferring heat. Let's break down the four main components that make it work: the evaporator, the compressor, the condenser, and the expansion valve. It all starts with the evaporator coil, located inside your room. The refrigerant enters this coil as a cold, low-pressure liquid. As warm air from your room blows over the coil, the refrigerant absorbs heat and evaporates, just like sweat evaporating from your skin. This removes heat from the air and cools it down. The cooled air is then blown back into your room by a fan. Now the refrigerant, now a warm gas, travels to the compressor, usually located in the outdoor unit. The compressor squeezes the gas, raising its pressure and temperature. Think of it like pressing your finger on a balloon to build pressure. This hot, high-pressure gas now moves into the condenser coil, also located outside. Here's where the magic continues. As the refrigerant gas flows through the condenser, a fan blows outside air over the coils, which cools the refrigerant down and turns it back into a liquid. In the process, the heat that was absorbed from your room is released into the outdoor air. Finally, the refrigerant passes through the expansion valve, which drops its pressure and temperature, making it cold again. It re-enters the evaporator coil, and the cycle repeats, again and again, constantly pulling heat from inside and pushing it outside. Right pointing finger emoji. If this explanation helped you see your air conditioner in a new light, like this video and subscribe to the channel for more science made simple. Now let's talk about why this knowledge actually matters. Understanding how air conditioners work helps us use them smarter. For example, you now know that an AC removes heat, not just cools air. So if your doors or windows are open, you're constantly letting more warm air in, forcing your AC to work harder. That means more electricity use and a higher power bill. This basic science also explains why regular maintenance is important. Dust on the indoor evaporator coil or clogged outdoor condensers trap heat, reducing the system's efficiency. And if refrigerant levels are low due to a leak, the entire process breaks down. You might keep running your AC without realizing it's not cooling because it can't complete the cycle. There's also the matter of environmental impact. The refrigerants used in older ACs, like CFCs and HCFCs, were found to damage the ozone layer. Newer systems use more eco-friendly refrigerants like R32 or R410A. Knowing this helps you make better decisions when buying or replacing an AC unit. In industries, this same science is used in refrigerators, freezers, data centers, and cold storage. From your kitchen to the cloud, air conditioning tech supports everything from food safety to computer performance. Even in hospitals, temperature and humidity control can be critical for patient care and equipment safety. So the next time you feel the cool breeze of your AC, remember, it's not magic. It's the science of heat transfer, pressure, and phase changes working behind the scenes to keep you comfortable. It's engineering that touches everyday life in a big way.